Hello and welcome to the TID Water and Power Podcast. I'm your host, Constance Anderson, and on this month's episode, we're discussing the Don Pedro Life Extension project. Later this month, the Don Pedro Project will celebrate its 53rd anniversary. From valuable hydropower to flood control and recreation, the project has served the district and our community incredibly well. However, as typical with aging infrastructure, Don Pedro needs to undergo a major life extension project to continue its valuable service. On this episode, I'm joined by TID's Director of Power Generation, Tim Payne, to discuss the various work being done as part of the life extension and what changes or improvements are coming to Don Pedro. Tim, thanks for joining us.
Thank you. Great to be here.
All right. So, Tim, this is actually your second turn on the TID Water and Power Podcast. You were previously with us when we were celebrating the 50th anniversary of Don Pedro, and that was back in episode 2.
Been a couple years, yeah.
It's been a couple years, so thanks for coming back and sitting down with us again. So let's start out with, for those who maybe haven't listened to episode 2, if you would give us just a little bit on your background and kind of how you became the Director of Power Generation for TID.
Sure. I started at TID in 2013, about 11 years ago. Initially, I was in the Water Resources Administration working as a civil engineer. I did that for about 5 years. Most of my work was within the dam safety program, dealing with the various TID dams. And then kind of had a change about 5 years in, became the chief dam safety engineer. So I did that role for another 5 years or so. And then in the last roughly 1 year, I've been serving as the Director of Power Generation.
Okay, very good. And so as such, you then become the de facto manager of the Don Pedro Life Extension project. Is that right?
That's right. Yeah. So technically, the program manager, we've got a lot of details that go into that project. It's a large project, multi-year. So so somebody's got to sit in that seat. Most of the other people are doing all the work. So yeah.
Well, we're glad to have you steering the ship and look forward to hearing more about that project. So let's start with a little background on Don Pedro itself. And so if anyone wants a deeper dive into Don Pedro, as I mentioned, they can go back to episode 2, which was the 50th anniversary of Don Pedro, where we talk a little bit more detail about the project. But can you kind of give us a quick overview so we know what we're talking about here today?
Sure. Yeah. The what's referred to as the new Don Pedro hydroelectric project was completed in 1971. That effectively replaced the old Don Pedro project. It's now submerged under the reservoir about a mile upstream of the new dam. The major components of the facility are the main dam, of course, the powerhouse. There's a large spillway. There's some gated and ungated auxiliary components to that spillway, a couple of auxiliary dikes, and then 2 primary conveyance tunnels, the power tunnel and the diversion tunnel. The dam itself is as a reminder, it's an earth and rock-filled dam, 585 feet tall. It's fairly significant structure, 5th tallest dam in the state and the 9th tallest in the United States, 855 feet above sea level. So it's relatively low elevation, right in the foothills of the Sierra Nevadas, not too high in elevation. And that holds about 2,030,000 acre feet of water storage behind the dam.
Very good. And how about the powerhouse? Can you give us some of the specs on that facility?
Sure. The powerhouse is a concrete structure at the downstream toe of the dam. It's got 4 vertical Francis units with a total capacity of 203 megawatts. Roughly 139 megawatts of that is TID's portion, and then the rest is MID's. We have a sharing agreement up there.
And that energy sharing agreement follows the same pattern as all of our other sharing agreements with MID, right? Kind of a 2/3, 1/3?
Right, roughly 2/3, 1/3, and it's the same split for the water as well as the power side, yeah.
Very good. And what about the spillway? The last time we saw some activity out of the spillway was 2017, and it's one that we hope to not call on very often. But what does that look like?
Sure. The gated spillway structure has 3 large radial gates. They're about 30 feet tall and 45 feet wide, so they're significant. In 2017 we conveyed a very small percentage of one gate, so that was a relatively small flow rate compared to the capacity of that structure. The auxiliary spillway is basically a long crested weir, just shy of 1,000 feet long, and the crest of that is 830 feet above sea level. So when the lake gets full, if the lake level exceeds that elevation, the gates are designed to open up and operate at that point, as well as the auxiliary spillway. So those function in tandem. That auxiliary spillway actually conveys a much larger portion of the total flow rate, roughly 350,000 CFS over the weir for a combined 525,000 CFS.
Wow, that's moving a lot of water. Okay. So in our last episode of the podcast, we sat down with Dan Severson, who's the AGM of Power Supply, to kind of talk about the value of hydropower in general. And so we've spent a good amount of that time discussing Don Pedro and the value that it brings to TID's overall generation portfolio. Can you kind of recap that for us real quick? Just the different ways that Don Pedro adds value to TID's operations?
Yeah, of course. There's the obvious economic value there. The energy source is water stored in a impoundment reservoir, which provides the energy, stored energy to create electricity, and that's a very efficient way to generate energy. Through the evaporation process and the precipitation process, it's all natural and renewable, and so. And carbon free, so there's that side of it. But also there's, the water side, there's definitely a nexus between the water and power side at the hydro plants, because we're not only generating electricity and power, but we're controlling irrigation flows down into our canal systems as well. And having this dam and power plant as a TID owned and operated resource allows us to have local control of that entire asset.
Yeah, that's really important. All right, so let's get into the Life Extension project specifically. So recognizing the value of hydropower and the existing and even increasing value of Don Pedro, there's an obvious desire, if not need at this point, to keep the facility operating smoothly. What are some of the factors at Don Pedro that led us to undertaking this Life Extension project?
Well, it's more than 50 years old, and inside of a powerhouse, as one might expect, there's a lot of electrical and mechanical systems and components. And if you just think about a 50-year-old vehicle, a lot of outdated equipment that's going to be in need of a lot of repair. And of course, we do maintenance over time. Since it was original, we've done routine maintenance and repairs and such, but certain things just get to a point where you have more and more frequent failures and forced outages. And in the early 2000s, we were seeing kind of a increased rate of those occurrences. And so that kind of triggered a lot of the planning for this project.
Okay, very good. And I understand that, as you mentioned, finding parts for a 50-year-old car would be difficult. And you've kind of experienced something similar with Don Pedro components as well. Is that right?
That's true. Yes, you've heard the rumors correctly. We've literally resorted to eBay and, making phone calls and scrounging around the country and the world for parts for certain things that are just basically obsolete, and they don't make those anymore. And so you got to get creative sometimes.
Yeah, probably a good indicator that's time for a refresh. All right. So I would imagine that the entire project isn't going to wear out all at the same time. So are you seeing different levels of resilience in different areas of Don Pedro?
Yeah, definitely. For example, the dam and the spillway structures, those are basically concrete and rock materials, very durable, long lifespan. certainly we have maintenance required for those as well. But inside the powerhouse, that's where we're really focused on, solving problems there with the mechanical components that fatigue or corrode. We've got carbon steel piping. We've got things that are submerged under the lake.
Sure.
Areas where things aren't just steel and components aren't expected to last forever. And then the electrical components, that's even more of an issue where you have a much shorter design life. If you just think about your phone and your computer and how long those last. We've got some electronic systems that are still in the plant from original. The control room, it looks like something out of an old movie.
We have heard it referenced as a Star Trek set before.
That's exactly what it looks like, yeah.
Okay. All right. So ultimately then, what are some of the goals of the Life Extension Project?
Yeah, Don Pedro has served the district incredibly well for the past 50 years and has provided tremendous value to the community here. And one of the primary goals is to get another 50 years is kind of the way we refer to that. We would like to extend the life and ensure reliability continues as it has been. And so it's an important piece of our carbon-free portfolio. So the value is likely to be even greater in the future than it has been in the past. That's kind of the overarching mission of this project.
Absolutely. And so there are so many components to this facility, whether we're talking about the reservoir, the individual generation units in the powerhouse, even the canyon in which it sits is something that, you guys perform maintenance on and keep tabs on. But from a high level, what work is being done to extend the life of Don Pedro?
Sure. The dam and spillway, like I mentioned, are performing very well, and we've done some minor projects there. They are not at their end of their useful life, other than some minor mechanical work with the spillway gates or hoisting systems, and just following robust maintenance and inspection programs on the dam safety side. Those are expected to continue. Aside from those structures, the Life Extension Project is basically split into two main phases. Mostly the around in and around the powerhouse, but we have two basic components: the generation components, and then what we refer to as the balance of plant. So basically, the generation phase it consists of the turbines, the generators, most of the components integral to the generation function, and then the balance of plant is the tunnels, the conveyances, gates, and valves. All of the ancillary equipment. And there's quite a bit of it around the plant. So those are the two major buckets that we're dealing with.
Okay. So if you would, let's start with the balance of plant then. How do you determine what individual projects needed to be included in this phase of the overall Life Extension Project?
Great question. So in 2010, when we began the planning of this project, the basic engineering process is first you got to start with the problem before you start working on solutions. And so we kicked everything off with a condition assessment. So we went system by system and component by component and reviewed every part of this facility, really with the goal of determining whether to replace something or refurbish or maybe do nothing. So we kind of started that process of identifying what the real problem areas were. Everything then had to be put into a sequence, into a plan. And the way we approached that was starting with, or the next step was to perform a risk analysis. For example, some of these components are used for generating electricity. Some of these components are used for flood control. So those kind of risks related to those assets were used to prioritize different sub-projects.
So, for example, a component related to flood control would be considered a higher risk need. Is that correct?
That's correct. So if it's a system needed for flood control, it was automatically put on a higher priority. And then even then, some components, if they fail, would not be a detriment to flood control capabilities. And so we looked at each component individually to determine risk. For the power generation side of things, we came up with a 1 through 3 scale for determining risk. For example, if something a component or a system, if it failed, were to take the whole plant offline. In the middle of summer, that can, depending on the season and the weather, that could be a grid reliability situation. And so we'll put the highest priority on those and build in, really high quality components, redundancy where needed. If having two pumps, so if one pump fails, the second pump automatically kicks on, that sort of thing. The second priority would be something that takes one unit offline, which is less of a grid reliability situation, but definitely a revenue implication and consequence. And then the lowest priority was something that if it fails, maybe you have some time to just go replace it, and there's not really any significant impacts. And so we use that scale to determine how much design effort needed to go into each thing.
Okay. And then, so it sounds like essentially all of the work that you're doing in balance of plant is really just to kind of prepare for that second phase that you talked about, which is the generation phase. Is that accurate?
That's exactly right. So upgrading and modernizing the components around the powerhouse was definitely a part of supporting that generation. So, yeah, exactly right. Like I mentioned, every system, the BOP systems, they were looked at with that same lens. Essentially, all the work that needs to get done to prepare for the generation phase. And some examples, like I said, the power tunnel, that's the main conveyance for the powerhouse to get the water from the reservoir to the turbine. There's quite a few gates and valves and systems used to convey that water and control the flow, and monitoring pressures and flow rates and such.
Very good. Okay, so then let's jump over to the generation phase. What can you tell us about that part of the project?
Yeah, basically, where we ended up with the design is essentially anything that's not embedded in concrete is being replaced.
Wow.
That is not typical. But as we, began planning into this generation design phase, we did an alternative analysis that basically we looked at refurbishment or replacement in kind of the main components, turbine generator, etc. And we looked at some different uprate and modernization options as well. And it was pretty interesting seeing the outcome of that. But that led us ultimately to fully replacing and upgrading all the three larger units.
And I like how you refer to it as the design and the design that you guys came up with, because as I have a couple questions for you a little later about how it was determined what some of these replacements would look like. And it's not just that we're replacing like with like, it's that you went through a whole process to determine what kind of components are going to go back into the powerhouse. So it truly sounds like it was an overall design had to be done for this project.
Right, exactly.
So with regard to the specific generation units, those are being fully replaced, but they're actually being upgraded as well. Is that right?
Yes. So of the 4 units, 3 are 55 megawatts each, and those are each being increased by 20 megawatts. So fairly substantial increase for those, roughly 1/3 increase to the nameplate capacity. Unit 4 is a slightly different, slightly smaller unit, and that one is actually receiving mostly a refurbishment and replacement in kind.
Okay. And for those who don't regularly work with capacity, can you tell us what it means when you say increase in nameplate capacity?
That's a great question. So the Federal Energy Regulatory Commission, FERC, they have jurisdiction over this facility. Most generation plants, they'll have some type of jurisdiction, and so really it's a FERC term that just rates the megawatt capacity of each unit and of the plant.
Okay. Thanks for that. All right. So I'm going to go out on a limb and just guess that a project as immense and involved as this one doesn't come cheaply. May I ask what the budget is on this project?
Of course. Yeah. We're approaching the $300 million mark. We're a bit over $100 million with our forecast for the balance of plant projects. And the generation phase is roughly $180 million at this point. So not all of that's spent yet. We're in the process, but that's what it's looking like overall. And just to point out, we we're always looking to, it's obviously a lot of money, to our customers, and we're, at every step of this, we're looking to find value engineering and optimize those costs as much as possible. For example, we're even applying for grants. We've, I think, applied for 2 or 3 this year. We'll see, still waiting to hear back on some of them, but, one of the Department of Energy, grants that we've applied for could mean up to $30 million of grant support for this. So that could be a huge difference. And of course, as a reminder, back to the TID MID cost share has that same 1/3, 2/3 split. So, MID is our partner owner of the asset, and we coordinate with them regularly. That, as we, progress through the project, they're helping with their role as well.
Absolutely. And while that is a big budget, I think that goes back to illustrating the value of hydropower. If we didn't see the value, if we weren't going to recoup from this project the money that we're putting into it, we would go a different direction. So I think that in and of itself kind of states how important hydro generation at Don Pedro is to TID.
Yeah, definitely. Definitely a lot of money, but great value as well.
Absolutely. All right. So when did the project actually begin, and when do you anticipate completion?
Yeah, it's quite a cruise through this. We started the planning in 2010, which is when we, had a few board meetings. TID and MID decided to kick this off, went into the planning phase around then. The first physical construction work began in 2013 with some of the BOP projects. We've still got roughly through 2029 to finish up. And of course, you never know, we might encounter delays, but as of today, we're looking for completion in 2029.
Okay. So physically, work has been happening then for over 10 years. How do you go about managing a project that is this wide in scope and this long in duration?
Yeah, sure. Well, there's around 40 balance of plant projects that have been completed or are still in the works or slightly in the future. These had to all be put into a priority and into a sequence. A lot of considerations went into that, putting that program scheduling together. Basically, in addition to the risk and the kind of complexity and the cost of each of these projects, we put things in an order that made sense. For example, on the diversion tunnel, there's several systems. With that system, the primary control gates that are in the middle of that tunnel system, that's what we use to control flow through our bypass system. In order to work on those gates, we have to isolate upstream with what's called the incline gate or a bulkhead gate that we close, and we're putting people and equipment downstream of that to do the work. And so we'd like to refurbish that bulkhead gate first.
Makes sense.
Just, for obvious reasons. And then for the bulkhead gate work and the control gate work, you have to dewater the tunnel and then at the end rewater the tunnel, which requires fill and ventilation systems. There's piping systems that allow the water to go in and out of that tunnel, to drain it and fill it. There's also air ventilation systems. When you drain it, the water comes out, air has to go in. So there's systems that, those systems we prioritized first. So basically we did the vent system, then the fill system, then the isolation bulkhead gate, and then moved on downstream to the control gates. And we did that entire diversion tunnel first before the power tunnel so that it would be reliable as we then start moving in the future into the generation outage where we take the power tunnel out of service. So every project had some kind of, logic put into it along those lines.
Sure. Well, and again, just going back to the sheer number of components that you guys are working with, there's a lot to coordinate. And like you said, I can see where the sequencing would be extremely important, because if you can't drain the tunnel to work on it, then there's no way you can actually get half the projects done that you need to.
Right, exactly. And speaking of coordination, when we move into power tunnel projects, gates and valves and other systems associated with that tunnel, if you have to drain those systems, you're now dealing with power tunnel outages, because if there's not a power tunnel that's watered up available to generate, then the units come offline, and that's been a big challenge for us. As the irrigation season, we usually generate when we're releasing irrigation flows. which is usually roughly March through October of every year. But also we need the power tunnel, both tunnels online for flood control season, which is officially October through April, but more practically it's like November, December through as late as June or July, depending on the water year. So there's literally no ideal time to take the power tunnel out of line. So every time we need that system down, we're looking at the best of not really great options. So which usually ends up being around October. So some of the things we've done to minimize the, generation impacts there is, for example, we'll use Turlock Lake, which is our downstream reservoir. As we're getting towards the end of irrigation season, say around September, we'll fill up Turlock Lake, pre-releasing those October flows. So we'll be able to generate in September out of Don Pedro, store that water in Turlock Lake. So then, October 1st, we can take the plant down, drain the tunnel, and really reducing those revenue impacts.
Absolutely. And kind of highlighting the amount of coordination. That's just one aspect of the amount of coordination that your group has to do with so many other areas around the district to make all this happen.
Right. Yeah. The project team definitely communicates and works with quite a few departments. I think at some point almost, I don't know, there's 25 or 30 departments, and this project team interacts with almost every single department. I
believe it. All right. So what are some of the tools that you're using to help guide a project like this?
Yeah, that's a really great subject. So there's a large team working on this project, and to make sure we have common goals and kind of a common mission and vision, so to speak. We've got a few key goals, and one of which we already mentioned is 50-year design life. So that's one of the common goals of every component of this project is to get another 50 years of life. That does not mean every component has to be replaced if it will not make it another 50 years. It just means in making decisions of whether you replace or you refurbish, it may be more cost effective to refurbish something, but you might have to redo it in another 20 years and then another 20 years after that. And so, for example, going from a carbon steel piping system to stainless may cost you a little bit more now, but in the 50-year life, it may be more cost effective. So those kind of things go into that objective. Also, we really focus every decision on risk. So using a risk-based decision-making process, similar to the pipe-in example, adding redundancy for something back to that 1 through 3 criteria. That's another big objective, and kind of making sure the team is all aligned on that allows us to work efficiently and independently and know that we're all, heading toward the same goals.
Very good. So you mentioned, obviously there's a large team that's working on this and multiple projects happening at the same time. What kind of unified approach is there to the project that helps kind of all these things happen simultaneously, but all moving in the same direction?
Yeah, so communication is obviously key in almost every scenario in life, and within this project team, that's no different. So one of the things we really put a lot of emphasis on is having clear roles and responsibilities for each team member. So from project managers to, subject matter experts to our consulting, engineering support staff, just making sure there's reduced overlap or redundancy, and also just clear expectations for everybody through the way. Another thing that we focus on is assigning any task, whether it's a project or a task or scope of work. We focus on assigning that task to whatever entity or individual is best qualified to perform that work. So in other words, not trying to bury things behind contractual boundaries. Obviously there's very robust contracts involved with a project like this, and we don't neglect that, but really focusing on, rather than burying subcontractors underneath the prime contractor just to make our job easier, we're focusing more on making sure every component of a project is handled by the best qualified outfit to do that work.
So if that means bringing in additional contractors, that's what you would do.
It may not be additional contractors, but more of we would be interfacing with say 5 contractors directly with direct contracts rather than having one prime contract. And so it does add a little bit more complexity, but it improves the outcome, and it's going to be more efficient in the end, and we're going to get a better quality product, which again goes back to the goals of, a 50-year lifespan of a reliable plant.
Absolutely. Okay. So I'm sure that you have run into some challenges along the way with this project. Can you tell us about any of those or any dilemmas you've had to overcome?
Yeah, of course. Delays and cost increases. I'm sure that's not a surprise to anybody. Just like, you have a project at home, you're gonna see that same thing. So those have been the biggest challenges. Being on a fixed calendar year budget is a challenge when things increase in cost or get delayed. That makes that difficult to work with for a lot of folks here. Some big drivers for that are, we're kind of past the COVID pandemic, but we're still heavy in a lot of the impacts of that issue. And so we're dealing with a lot of supply chain issues, lead times, but also just staffing and workforce in a lot of areas is down. And so it's not only are things taking longer to be delivered, but in certain areas we're getting less interest because the industry is so overwhelmed with renewable projects getting built and other things, especially the electrical components. We're having some challenges, even just getting people to bid on projects sometimes, which is surprising.
Wow.
But we've had to get creative there to make sure we're keeping everything moving.
Well, and again, going back to what you had said earlier, you don't necessarily just want to take the one bid you got because that's the only bid you got. You want to make sure that that's the best entity or the best company for the job.
Right. Yeah. And as a public agency, we bid things out and we strive to get at least 3 competitive bids on every contract. And yeah, sometimes if you get one bid, we have a decision to make. We follow the process. We could award that. And, at times we've decided that we can afford a little bit more delay on something. And, we've actually taken some opportunities there to rebid. And we've actually brought costs down substantially by just being focused and diligent and creative with trying to get the best qualified folks and the best value we can with different things.
Very good. Now you mentioned the lead time of getting some of these components and equipment in, but I understand that's also kind of maybe hindered a little bit because you've got components coming from all over the place.
Yeah, literally around the world. The turbine shutoff valves that we have installed in the past few years came from Poland and Switzerland. We're currently fabricating the turbine runners that were initially started the fabrication process in the Czech Republic, which are now undergoing final machining in Canada. The turbine shafts were founded and originally machined in China, and they're being finished up in Brazil. So literally all over the place, things coming from India. Some things are coming from the United States. A lot of the larger components they just don't make them here. So they're coming from all over the place. And just another note, everything is custom made. That's just kind of a thing with hydroelectric plants is there's a lot of commonality in similar designs, but every plant is unique and has custom fit components. And so everything's got to be carefully engineered with very tight tolerances to fit at the site.
Sure. Absolutely. Wow. That's interesting. A very international plant by the time it's done.
Exactly.
Okay. So let's talk about some of the specific projects under the Life Extension project that have been completed so far.
Yeah, so of those 40 balance of plant projects, we've completed over 30 of them. So in quantity, we've made pretty good progress. I think as far as that overall budget, we're probably around 70% complete. Some of these later projects have to be, for various reasons, timed a little bit closer to the generation outages or even simultaneously. So we've got a few of those that are still in process. Originally, the intent was to do as much of the balance of plant work as possible before the generation, just due to site logistics and constraints there. We've completed things like our penstock, the power tunnel portion as it approaches the powerhouse is steel lined. And so there was an old coal tar epoxy coating on that was at the point of failure. So we've blasted and recoated that. I think we did that project over 3 years just because that tight time frame for the outages. So we had to split that one up. So that's been completed.
Right.
The entire power tunnel system from the bulkhead gates to the control gates have all been replaced or refurbished. Turbine shutoff valves, which are large valves just upstream of each generation unit. Those have been replaced between 2019 and 2022. And just some other assets like rockfall protection, things you wouldn't think about where, that we have a couple rocks fall down here and there, and we, did an assessment and found out there's a couple of things that, either weren't addressed originally or were addressed, and they've kind of, the site conditions have changed over time. So we did some fall protection improvements to protect, personnel. Obviously, we're going to have a lot of people over the next few years at the plant. So for personnel safety as well as equipment safety, you don't want a big boulder, coming down on top of a brand new generator.
Absolutely. And I think just real quick to mention for those who have not seen Don Pedro, it literally sits in a canyon on the backside of the dam with mountainsides on either side of it. So that fall protection is definitely something to take into consideration. Yep.
That's a great point. The gantry crane was one of the kind of momentous projects. We just finished refurbishing and upgrading the gantry crane. It's had years and years of ongoing issues. Seemed like for the last few years, every time we operated, it's kind of like a 50-50 chance that something might malfunction or break. So it's been a challenge. We finally got that refurbished, and part of the delays getting that refurbished was we were purposefully waiting to refurbish the crane until we knew some preliminary design information on the new generators. They are uprated generators, which means they're slightly larger, which means they weigh more. And so the generator lifts are the heaviest lifts at this facility. And so we wanted to make sure the crane was able to lift that. So we did an uprate on the crane as well. Fortunately, we were able to do some minor structural modifications and get that crane refurbished and uprated. So it's now ready to do its job.
Yeah, it would be a bummer to refurbish the crane and then find out that it didn't quite have the capacity to lift the new parts into place.
Exactly.
Oh, boy. Okay, but speaking of, I think this is probably a good place to talk about just the sheer magnitude of some of the equipment that you're working with. Because if you have to go so far as to uprating this giant crane to be able to move some of these pieces, tell us a little bit about what you're working with.
Yeah, that's a great question as well. Most people who just drive across the dam or head up to the lake, most of the equipment is concealed. It's either underground or inside the plant, and so you'd never know just driving by what's really down there. So the fixed wheel gate is one of the larger components aside from the generators. It's a big square rectangular gate that's 17 feet wide, 21 feet tall, and it weighs over 80 tons.
Wow.
And that's the emergency kind of like break the glass, pull the red lever, shut off if we had a catastrophe at the plant with the generators. That's the emergency shut off. So it's large gate. That's actually been replaced. The diversion tunnel itself, which is the bypass for conveying flows when the power plant's offline for maintenance or other purposes, it's a 30-foot diameter tunnel, 2/3 of a mile long. And if you imagine your ceiling in your house is maybe 8 or 9, 10 feet tall, maybe this is 3 times that. Wow. It's a very humbling structure just to see the inside of. The turbine shutoff valves I mentioned, it's an 8-foot penstock. As the penstock approaches each of the larger units, these valves, it's basically a giant butterfly valve, and they're roughly 9 feet in diameter, and the forces experienced on these valves are very heavy. They're very large, and they're very important because when closed, you have the lake pressure inside the power tunnel, putting force against these TSVs just based on the surface area inside the valve at 200 something psi. It's over 2 million pounds of static force just when it's closed. And these turbine shutoff valves are designed to close with flow. So you've got this massive tunnel, like a freight train of water flowing through it, and it has to close under flow. And so the forces are just tremendous. It's very humbling, not only to see these valves being lifted into place and installed, but just watching the operation. The penstock pipe is, I think it's around 3/4 inch thick steel walled pipe, and it actually stretches, and it's designed to stretch. When these valves close, the whole system moves. All the piping and flanges and electrical conduits that connect to the TSVs have to be designed to flex and move around all that force.
Wow, that is wild. And yeah, very humbling to consider the magnitude of all of this equipment and the way that it all works together to make things happen. That's impressive. Okay, so obviously these aren't the type of parts that you would just go down to the hardware store and pick up. How do you store an 80-ton piece of equipment?
Yeah, not easily. Not only is the site constrained spatially, it's in a canyon. There's not a lot of extra space there. We do have a couple warehouses on site, but there's a lot in those, and so site logistics is definitely a big challenge. It takes planning, knowing what's going to arrive when and what different components have to have what types of climate control conditions, or can they be stored outside or under a tarp, or different things like that. Some of the large hydraulic cylinders or generator shafts can bow if they're not stored a certain way, or they have to be rotated every so often so they don't get a bow. These, again, these are very tight tolerances. And you just generally, you don't want to have to do large lifts and picks more than you have to. So when something's offloaded, if you can time a delivery in time for installation versus having to store it and offload it and then reload it back again. So all of this stuff has to be looked at. So a lot of work goes into just the site logistics aspects of the whole project.
Yeah, absolutely. Gosh, the coordination is never ending. And I think it's kind of important. I want to go back to the projects that have been completed so far, because you mentioned the difficulty in finding the right time to take an outage. And I just kind of want to reiterate that most of these projects that have been completed are happening simultaneously to running the plant, that we, as much as possible, we aren't going to take outages. While we might have a unit come down for a stretch of time, you don't have the option to just shut down the plant when you want to, or when it's the right time to, to do one of these replacements. So that's an incredible amount of coordination and balance that has to happen to make those projects come to fruition.
Absolutely. Yep.
All right. So now let's talk about what we have to come. So you mentioned we still have another 5 or so years to go on the project. What's in store?
Yeah, so as far as the balance of plant projects, a couple of the larger outstanding work is really on our low voltage and medium voltage systems. In your house, you've got 120 volts. At the site, we've got some 120 volt equipment, but it goes up from there, 480, 12.8 kV. We've got, the medium voltage. I couldn't even tell you off the top of my head, but we're getting up into the thousands and thousands of volts of equipment, and it's throughout the whole plant. It goes through the plant, into the switchyard, up the dam we've got unit substations up near the top of the dam, the spillway, the fixed wheel gate site. There's power and controls kind of strewn throughout the facility, some of which is obsolete, just like everything else, some of which is being uprated to handle the new units. So all of that, we're actually just beginning in the next month or two, about an 8-month period of doing site work, replacing and upgrading a lot of that equipment. So that's a large balance of plant phase going on right now. And then immediately following that, kind of right around the fall 2025 period is when we're planning to start the first generation unit replacement. At this point, we're looking to start with unit 2, and then go, roughly one per year from there.
Why start with unit 2?
Yeah, that's a great question. So we've got a tentative plan that's firming up as we get closer to start with unit 2 because of the stator condition. So all of these generators are fairly old, as we've discussed, and they're functional at this point. They're still operating, but they do have some problems. So the stator, which is the outer portion, the stationary portion of the Unit 2 generator is in the worst condition. So again, it's operational, but it's degraded. And so that one is in the worst shape. We're going to do that one first. Unit 3 is planned after that. It's, the next worst condition out of all the stators. Unit 4 being the newer of all the units. It was installed in the late 1980s. It's last in the series. In the meantime, we've got some derated, condition on these units, just to help them get there to that finish line when they're ready to come out of the plant for replacement.
Very good. All right. So after generators, then what?
Well, at that point, one of the last major balance of plant projects will be the switch yard and all of the various protection equipment. That's scheduled to be basically in parallel with the unit outages. That's going to be a big project as well, and it's got some complexity that requires it to be done in parallel with the generators.
And then when the individual unit replacements start, what does that mean in terms of the amount of time that they'll each be out of service?
Yeah, so the first one, like I mentioned, scheduled to start fall of 25. We think each outage will take roughly 10 to 11 months to remove everything, reinstall, and get everything tested and commissioned. But we're going to plan to start each unit just so we can have everything in a reliable, planned way. We're going to have everything scheduled to start 1 year apart. So that does give a month or two in between to kind of let things run a little bit, give the teams a little break, and then get back onto the next one. So as we go through in time, as each unit comes back online, we're hopefully reducing the risk of, unplanned forced outages due to older equipment. So that's the plan at this point.
Okay. Now, and we mentioned this a couple times, that TID and MID are partners on the project. How will this affect the amount of energy each utility receives when there's an entire unit out of service?
Well, again, TID or MID is a 1/3 partner, and so basically the generation energy and revenues are split along those lines. Now, the way we do this, the accounting for this, is that Unit 3 is actually controlled and dispatched by MID directly. That's not a full 1/3 since there's 4 units, and so TID operates and controls and plans operation of the other 3 units. And basically the power and the water deliveries get trued up at the end through an accounting process. So we true it up to be that 1/3 equal share.
Okay, very good. All right. So I think we mentioned earlier that as we're looking at the renovation of each of these generator units, we're not just replacing like with like, but there are some upgrades happening, as you mentioned, in capacity, but there are also some other decisions that were made as far as what went back into the plant. Can you tell us about that?
Yeah. So the major components, there's thousands and thousands of pieces and parts, of course, but the major components are the turbine runner, the generator, and governors and exciters. Those are the main components of controlling these units. And all of that is being upgraded, as we discussed, from, for the bigger 3 units from 55 to 75 megawatts. Unit 4 will retain the existing nameplate capacity. But we're also modernizing and getting everything up to date from a modern standard. So one of the big components of that is our plant control system. We're installing a DCS, which is a distributed control system, which will basically we'll be pulling out all of those Star Trek style panels and levers and knobs and basically installing what you'll see in the end is a bunch of computers and screens and monitors. So it'll all be digital at that point to be able to do a lot more things with monitoring and diagnosing and maintaining the system.
And obviously, modernizing components makes sense, but how exactly did you come to the decision on what units exactly and how much of a capacity uprate, and how were these decisions made?
Right. So very thoughtfully and very carefully is how I would put it. We did an alternative analysis back around 2018. We started that as we were starting to move towards the generation phase. We built a model through some consultant help of ours. We ran several different alternatives in that model. So alternatives being different configurations of equipment, different uprates to the units, and different kind of hybrid configurations of the units themselves as well. For each of those alternatives, we ran different scenarios. So, for example, would TID uprate or modernize the upper main canal system or not? So that's a constraint on the operation of Don Pedro. And so we looked at those types of scenarios. And of course, lots of sensitivities of, for example, the cost of the project, the value of hydropower into the future. So we looked at a bunch of sensitivities, and kind of, we basically looked at hundreds and hundreds of combinations of scenarios, alternatives, and sensitivities, and the overwhelming winner from a cost benefit ratio standpoint was what we called alternative 3, which was kind of a mid-level uprate. That's this 20 megawatts per unit, 1 through 3 uprate, and that's what we ultimately ended up moving forward with. It was kind of a mostly obvious best alternative. You can spend more, but as you spend more and uprate further, the incremental benefits somewhat decrease, and so that ended up being the best choice, the best value for the project.
Very interesting. Okay. All right. So we've talked a little bit about the timing of the project as we're moving through all of these multitudes of projects that are included under the whole Don Pedro Life Extension project. But there was some timing in play with when we specifically could prepare for the project as it lined up with the relicensing process that we are also in the middle of with Don Pedro. What did TID's application for a new generation license mean to the Life Extension project?
That is a really great question. So up until 2018, we were required to wait to do this generation phase of the project until we had the new FERC license. In 2018, there was a regulation within FERC that changed that allowed us to pursue what's called a non-capacity amendment. So essentially, we applied for and received this, what's called an NCA amendment with FERC that allowed us to essentially decouple relicensing from the project. That allowed us to move forward with planning and design, and everything's just been cruising forward from that point.
All right. So you've kind of touched on it as we've moved through our conversation today with regard to a project that is going to, in duration, last almost 20 years. With multiple projects happening simultaneous to day-to-day operations and making sure that the plant is consistently generating hydropower. It's not like anyone on your staff can just kind of abandon their normal job duties to make this happen. So how do you find the bandwidth to make all of this happen, to get all of this done?
Yeah, that's an interesting subject. So yeah, it's definitely a team effort. It takes a lot of people doing a lot of different things, just to keep all of the balls in the air with the project. We've got roughly 5 TID engineers who are acting as project managers for different sub projects or tasks. Like you mentioned, all of which, or most of which have full-time jobs doing other things at TID. So, it's definitely a challenge balancing the workload. On that note, we actually, in addition to the 5 TID engineers, we've got 3 staff augmentation engineers who are subject matter experts in hydropower or electrical engineering, that are basically also acting as project managers, managing and the contracts with contractors, engineers, suppliers, all of that. There's so much to handle there. On that side, just the engineering side alone, outside consulting engineers, we've got roughly 20 individuals who, not all of them are full-time. I would say on average, they're probably half-time. Some are more, some are less, but there's roughly 20 outside engineers who each have key roles for handling, turbine runner supply contracts or governors or exciters. All these large multi-million-dollar contracts takes a lot of time putting together the designs and the bid packages and managing the contract execution and different processes like RFIs, which is a request for information. We've got our turbine generator contract. We're up into the thousands range of just formal communications back and forth with the suppliers. So there's just an overwhelming amount of day-to-day engineering and contract management that goes on. So these, 8 or so TID or staff aug engineers managing all of those projects and making sure we have up-to-date budgets and schedules and all this coordination that happens with the other departments. So there's a lot going on. It does take a lot of people's time to try and keep up with all of that.
Yeah, absolutely. All right. So after this extensive project is complete, what happens next?
Well, the work will not stop there. As we've done routine maintenance and repairs for the last 50 years, that's going to continue as well. There are not only drawings and specifications that get developed with these projects, but also operation and maintenance plans and binders that get developed, some by the suppliers, some by our engineers. The system overall has to have written documentation of how to take care of things into the future. And so those are being updated as well to kind of make things reliable for the future. So one of the things we're looking to improve is the original set of binders kind of focuses on tasks that are daily, monthly, annually requirements for maintenance and monitoring and such. We're looking to put together more of a 50-year lifespan O&M binder that kind of looks at some of these large gates that are submerged under the lake. Every so often we might want to pull that out and recoat rather than wait till it gets to a point where it's so degraded that it has to be replaced. Those sorts of things.
Got it. Okay. So kind of like an overall service plan for the new equipment.
Right. Exactly.
Okay. And you mentioned there'll be continued maintenance, just as there always has been. I would also imagine that with all of these new modernized controls, there's a bit of a learning curve there for the operators themselves.
Yeah, definitely. We have these new binders for each system that will be at the plant for these guys to troubleshoot issues that as they arise. We include training from each system supplier to make sure our staff knows all the intricacies of each system so they can maintain it. Learning the new plant control system is going to be a huge improvement. The interface for those operators will be very different, as we mentioned. Moving from levers and knobs to more of screens that report real-time data and trend lines of operational temperatures and pressures, and there will be a lot more information at their fingertips to really help improve proactive maintenance moving forward.
Awesome. Very cool. All right. So the project, as we mentioned, has been underway for over 10 years. Do you have any interesting stories you can share that have come out of the work so far?
Wow. Yeah. Probably too many to share here. There's been so many great experiences watching each one of these projects get completed and be turned over to the operations side. One of the kind of memorable experiences was 2017. We as with every one of these projects, we're looking to value engineer it and optimize it. And one of the big impacts is, like I said, taking the full plant offline. There's a large revenue impact there. So in 2017, we attempted to put multiple large projects in one outage, and that was extremely challenging. We learned a lot of lessons in that. It was 2 to 3 months of 24/7 shifts. Some of the contractors are maybe more used to that. Our engineering folks, not so much. And so it was a huge learning curve. Working 12 hours with a 13th hour of shift overlap and then an hour drive each way to and from the site, 7 days a week was not easy. But that work had to be done. And so we did it, and it was successful. We got through it. But it was, there were 3 different work locations, 2 within one inside the plant, doing a lot of equipment replacement there. At the top of the dam was our fixed wheel gate, that large gate I discussed. That gate, it hangs 350 feet down a shaft.
Oh, wow.
And so just the the people aspect of getting workers in and out of that site was challenging in itself. And then a third work site on the lake, the power tunnel bulkhead gate is actually under the lake, several hundred feet underwater. And so we had a barge mounted crane and a crew of divers there pulling out the old gate, installing the new gate. So all of these 3 work areas at the same time. There was a primary and a backup for each spot. So just the amount of coordination, it was intense. Like I said, we got through it, but quite a story. We all love talking about the fall of 2017 outage. Like I said, learned a lot of things. And it's kind of helped kind of inform future outages as well, to kind of maybe have a little more balance of what we try to bite off all at once. But yeah, all of the projects have been really, really enjoyable and satisfying. Like I said, couldn't do this without all of the really fantastic people working on the project. Really, really committed, dedicated, and very smart people. So I'm very glad about that, having these people much smarter than me to do the technical part of the work.
Oh, that's awesome. And I would imagine when this does finally wrap up, that'll be a huge point of pride for anyone who has remotely touched the project.
Yeah, definitely.
Awesome. All right. Well, Tim, thanks for joining us today. We appreciate the update on the Don Pedro Life Extension project, and wish you the best of luck in completion.
Thank you.
Thank you for tuning in to the TID Water and Power Podcast. You can find TID on Facebook at facebook.com/TurlockID, on Instagram and Twitter at TurlockID, and on LinkedIn as the Turlock Irrigation District. I'm your host, Constance Anderson. We'll see you again next time.